Hello and welcome to another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 1, Lesson 2 on variables and expressions. So we start off in Math 8 with a unit of algebra. And we do that so that we can kind of lay the basis of having some tools of algebra to then use in geometry, coordinate geometry, geometric modeling, and a lot of other things that we're going to do in the course. And probably the two most fundamental ideas in all of algebra is the idea of variables, letters or other types of symbols that represent unknown numbers, and expressions, where we combine variables together with possibly other variables and other numbers that are known. So today we're going to be looking at variables and expressions and reviewing some of the basic ideas about them. Let's get right into that with the first exercise. All right, exercise number 1. Evaluate each of the following expressions for the given value of a variable. Show your substitution. All right, so before we even start to evaluate and whatnot, let's take it from the most basic idea. Letter A says n plus 12, right? And all that means is that I've got some unknown number that I'm calling n, and I'm adding 12 to it. That's all it means. And in fact, n plus 12, that expression based on the variable n, has no value until I give you a value of n. And in this case, it says for n equals -2. So let's substitute -2 in for n. It just means I'm going to replace n with -2, and I'm going to see what calculation I get. So here it goes. N becomes -2, and I'm simply doing -2 plus 12. And of course, we know that -2 plus 12 is positive 10. Now, in letter B, we're going to go through each one of these together because it's very, very important. Letter B, we have the expression 8 times t, right? Because that 8 is simply sitting besides the t, it implies multiplication. There is no multiplication symbol. And in fact, you'll have a lot of math teachers which will call this expression 8t. Literally, because the idea is, well, if I've got 8 times t, that means I have t plus 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 t. That starts to sound funny after a while. But the idea is that I literally have 8 t's that are all adding together, right? Now, of course, when I actually specify the value of t equals 3/4, all I'm looking to do now is multiply 8 by 3/4. So let's do that together. Right? And if I substitute 3/4 in there and I do that multiplication, I could do it in a variety of ways. I can do, 8 divided by 1. I could do cancellation. I could get 24 divided by 4 and get 6. One way or another, though, you need to be able to get 6 because you're multiplying a whole number in a fraction, and you know how to do that. In letter C, where we have a fraction, y fraction bar 8, a lot of math teachers will simply say y over 8, or y divided by 8. We're almost always in algebra going to specify division using the fraction bar and not using the division symbol. You will almost never see that in algebra, the division symbol, like that, okay? But in this case, we specify y equals -24, and let's see what we get. Right? Obviously, if we substitute -24 into that fraction, we get -24 divided by 8. Because we have a negative divided by a positive, we have a negative result, and 24 divided by 8 is 3. So our answer is -3. All right? Pretty easy. Okay. So the idea is an expression is simply a combination of variables and other numbers using addition, subtraction, multiplication, division, sometimes exponents, things like that, right? And expressions generally have no values until we're given the value of the variables that make up the expression, because an expression could have more than one variable. Let's keep going on our very basic algebra review. Now, obviously, expressions can become more complicated. And then if we need to evaluate them, we need to know the order in which we evaluate them. And that all boils down to order of operations, right? Now, you've been seeing this for years and years. But just to keep in mind, right, the steps in order of evaluations. If I'm evaluating a complex mathematical expression, right, the first thing I need to do is evaluate quantities that are within parentheses or that are grouped together. Perhaps they're all in the numerator of a fraction or they're all in the denominator of a fraction. The second thing I need to do is I need to evaluate any kind of exponents. So if I'm raising a number to the second power or the third power, the fourth power, I need to do that exponentiation. The third thing I'm going to do is any kind of multiplication or division that occurs in the expression, and I'm going to do that from left to right with multiplication and division sort of tying, if you will, right? And finally, the absolute last thing I do in any evaluation is add or subtract. And again, working from left to right. So yeah, let's use our order of operations to actually now evaluate a lot of different algebraic expressions that are a bit more complicated. Let's get into that in the next exercise. Here we go. Exercise number 2. Evaluate each of the following expressions for the indicated value of the variable. Show your substitution. Simplify all fractions, parentheses, division. All right? So we want to be able to think about fractions as fractions. We also want to think about them as division. So when I look at letter A, right, where I have the expression 1/2 times x, or just 1/2 of x, plus 5, let's do the substitution together and then talk a little bit about the order of operations, right? So what I'm going to be doing in this problem is I'm going to be substituting in the 6 for x. Many times we like to put whatever variable we're substituting in parentheses. Now, the multiplication of 1/2 times 6 has to come before the addition by 5. 1/2 times 6 is simply the number 3. And then, of course, we can do that addition at the end. 3 plus 5 is 8. All right, step by step, multiplication comes first. Actually, what comes first is the substitution, then the multiplication, then the addition. And all this tells us is that for the expression 1/2 times x plus 5, the value when x is equal to 6 is 8. All right, let's do one that's got a little division in it, one that's got a little exponentiation in it, and then maybe you can work on a few of them on your own. Let's do letter B together. All right, I'm going to put in a -2 wherever I see a y, and that actually occurs twice in this expression. So I'm going to get -2 plus 10 over -2 minus 2. Now, -2 plus 10, we want to do everything in the numerator, everything in the denominator before we do the division. So -2 plus 10 is a positive 8, and -2 minus 2 is a -4. We can think about that as -2 plus -2, right? Because we now have division, and a division of a positive by a negative, we know that the final answer is going to be negative, and 8 divided by 4 is simply 2. So we get a final answer of -2. Let's take a look at letter C. Here we have 2 times t squared. And again, this is where order of operations is so important, because I need to figure out, am I going to multiply t by 2, take the result and square it, or am I going to take the value of t, square it, raise it to the second power, and then multiply by 2? Well, our order of operations, remember, says that we must do the exponent first. So let's do the substitution and then talk about how we get that final answer. All right, so I'm going to put that -3 in for t, and again, notice how I put it in parentheses. Okay, now -3 squared I have to do first, and that's -3 times -3. A negative times a negative is a positive, so I'll get positive 9. I then do 2 times positive 9, and I get positive 18. Again, keep in mind how different of an answer we would have gotten had we done the multiplication first. Then we would have had 2 times -3, which would be -6, and then we would square it, -6 times -6, and we'd get positive 36. A very different answer than positive 18. And that's why we need to have order of operations, so that we can all agree on what a calculation should turn out to be. Honestly, if we didn't, there'd be pure and utter chaos in math. All right, so here's what I'd like you to do. I would like you now to pause the video and take a few minutes, this could take you up to 5 minutes or so, to work through what the value of each one of those expressions is when you substitute the value of their variables. Then we'll come back, we'll do all 3 of them, all in a row, take a look at the answers, and then move on. All right, let's do it. So for letter D, we're going to substitute a 7 in for x, and then we must do this multiplication first. So 3 times 7 is 21. Now 10 minus 21, you can either just figure that out in your head, or you can think about it as 10 plus negative 21. Either way, we get a final answer of negative 11. When we take a look at letter E, we're going to substitute m equals 4 for the variable m. Here we've got negative 2 times 4 plus 15. Again, we must do that multiplication first. A negative times a positive is a negative. So we'll get negative 8 plus 15. And a negative 8 plus a positive 15 leaves us with a positive 7. Finally, maybe the most challenging one, we're going to put 2 in for y in the numerator, but we also have to substitute it into the denominator. In the numerator, this is going to be 2 to the third power. In the denominator, it's going to be 10 times 2 plus 4. Now, 2 to the third power, we might have to think about that a little bit. That's 2 times 2 times 2. 2 times 2 is 4, times another 2 is 8. So in the numerator, we have 8. In the denominator, we have 10 times 2, which is 20, plus 4. So finally, we have 8 over 24. Now that's not 24 divided by 8. That's 8 divided by 24. We can divide out an 8 from both the numerator and denominator to get a final answer of positive 1/3. All right? So we just have to be careful. We have to follow our rules in terms of the order of operations, and we have to keep in mind what we know about positives and negatives. All right, very important for you to be able to accurately and somewhat quickly evaluate expressions or the values of expressions when you know the values of variables. Don't get me wrong, if the value of a variable was an ugly, ugly decimal or ugly, ugly fraction, we might take the calculator out right now and to help with some of these evaluations. But not on these kind of problems. Now these, we want to get that mental kind of workout in terms of the signed integers. Let's keep moving on. All right, equivalent expressions. There is, again, almost nothing in math that could be more important than this idea. You see, sometimes two algebraic expressions that have variables in them, look different, but always give you the same result if you put in a particular value of x or m or whatever. All right, anytime you have two expressions that give you the exact same value when you substitute the same values for their variables, those expressions are known as equivalent, and they can kind of like swap for each other. So let's take a look at a very, very simple example of this in exercise number 3. Consider the two expressions shown below. Expression number 1 is the quantity x plus 7 plus 3. The second expression is simply x plus 10. Letter A asks us to evaluate both expressions for x equals 10 and x equals negative 4 and to show our substitution. So let's talk about this. This is actually going to take a little bit of work because I literally want to figure out what this thing is when I put in 10 and negative 4. And then I want to figure out what that one is when I put in 10 and negative 4. So there's quite a bit of work, but let's go and work through it together. I'm going to just raise this on the screen a little bit. All right, so let's do expression number 1, right? And maybe let's use our x equals 10. So what would that be? That would be 10 plus 7 plus 3. And order of operations, whoops, plus 3, not plus 7. And order of operations says we must do 10 plus 7 first. That gives me 17, plus 3, and then that gives me 20. Now in terms of x equals negative 4, a little more work here. Well, not a little more work, but a little more thinking because of the negative. I'll have negative 4 plus 7 plus 3. Negative 4 plus 7 is positive 3. Positive 3 plus 3 is 6. All right, so simple enough. And again, all I know is that that expression, when I put 10 in, gives me 20, and when I put negative 4 in, it gives me 6. Now let's see what happens when we put 10 and negative 4 into expression 2. So for expression number 2, where I've just got x plus 10, when I put 10 in there, I get 10 plus 10, whoops, 10 plus 10, and that's equal to 20. On the other hand, when I put in x equals negative 4, I'll get negative 4 plus 10, and that's positive 6. And what, of course, I should notice is that for both of these two values of x, the two expressions gave me the same value, the same output, if you will. Now, that's not proof positive that the two expressions are equivalent, but it is some proof that they probably could be. In fact, if we had gotten different numbers when we had put those same values of x in, that would tell us the two expressions are definitely not equivalent. But this leads me to believe that they probably are. So let's talk about what property of real numbers and of operations allows us to say these two are the same. And that's letter C. I'm sorry, that's letter B. What property of real number addition justifies that the two expressions are equivalent? Well, let's talk about that. Let's take a look at the two expressions. One of the expressions is x plus 7 plus 3. The other expression is x plus 10. Well, we could use what's called the associative property of addition, right, to rewrite the first expression so that we add the 7 and the 3 and then add it to x. But that would give us the second expression, right? In other words, and this probably is no great surprise to you, oh, I don't have to do the x plus 7 first and then add the 3. I can actually do the 7 plus 3 and get 10, and then do x plus 10. And so the associative property of addition allows us to really take this more complicated expression and turn it into the more simpler expression by grouping the addition of 7 plus 3 together. Okay? Let's take another look at where the associative property in real numbers comes up. Exercise number 4. Consider the expressions 2 times 5x and 10 times x. Letter A asks us to evaluate each expression for x equals 3. Show your substitutions. Well, here's what I'd like you to do. I'd like you to pause the video right now, evaluate this expression, and evaluate this expression when x is equal to 3, and see what values you get in both cases. All right, well, let's do it. That first expression, 2 times 5x, right? Well, if I put 3 in for x, maybe I'll use the dot notation here for multiplication, right? Then order of operations says I must do 5 times 3 first, right? And then I'll do 2 times 15, and I'll get 30. So that's this one. On the other hand, if I substitute 3 into this expression, I simply have 10 times 3, which is 30. So it appears that these two expressions might be equivalent because when I put in a value of x into both of them, they gave me the same output. And of course they're equivalent for the same reason, because multiplication is also associative, and that's letter B. Let's take a look. Show using the associative property of multiplication that the two expressions are equivalent. So again, just to recall what the associative property of multiplication is, the associative property basically says, look, if I've got something that looks like this, a times b times c, I could do the a times b first and then multiply it by the c second, right? That is the associative property of multiplication. So in other words, if I have something like this, 2 times 5 times x, which really implies that I should do the 5 times x first and then multiply by 2, I can regroup the multiplication and do 2 times 5 times x, which is equal to 10x. The associative property of multiplication, which says, hey, you know, I know it looks like I have to do 5 times x first, but I actually can do 2 times 5 first and get 10 and then get the x. And that's important. And we're going to be doing a lot of that almost without thinking about it, but you do want to understand this is just a property that real numbers have when being multiplied together. Let's take a look at now how we can put these two properties together to do some more simplifying work in terms of expressions. The distributive property. All right, this is an amazingly important property. Okay, and it basically says if we have a sum or a difference that's being multiplied, we can multiply each part of that sum, all right, and then add, or we can multiply each part of that difference and then subtract. The same thing also works with division. If I have a sum that's being divided, I can divide each part of that sum and then add. And if I have a subtraction problem that's being divided, I can divide each part of the subtraction problem and then subtract. The distributive property comes up all the time when we're trying to create simplified equivalent expressions. So let's take a look at exercise number 5. Let me just move it to the top of the page, and then let's read through it. Use the distributive property to rewrite the following expressions in standard form. All right, so let's kind of go through these together. Again, the distributive property is so important. So we have 8 times the sum x plus 4. And literally the distributive property would say, I can do 8 times x plus 8 times 4. Now 8 times x, I can't really do anything with that except write it as 8x. But 8 times 4, obviously, we can write as 32. Okay? And this we want to be very good about. I multiply x by 8, I get 8x. I multiply 4 by 8, and I get 32. Now let's take a look at one that's a lot more complicated because there's negatives involved in various numbers. Negative 5 times 4y minus 3. Let's do that one together. All right, so I distribute that negative 5, and I literally get negative 5 times 4y plus negative 5 times negative 3. Actually, maybe I shouldn't jump to that so quickly because I kind of changed that subtraction into addition really fast. Maybe I should do this, minus negative 5 times 3. Now, of course, negative 5 times positive 4 is negative 20 times y. Negative 5 times 3 is negative 15, but now I'm subtracting that. That doesn't look like a y. There it is. So I'll get negative 20y plus 15. Let's take a look at this answer kind of in light of what we started with. What you really want to be able to do in a problem like this eventually is not have to write out all these steps. You want to be able to say, well, negative 5 times 4 is negative 20. And then I really do want to think about this as negative 5 times negative 3 giving me plus 15. Right? I don't want to have to minus negative 5 times 3 minus negative 15. Oh, that's positive 15. Can you do it? Sure, but it's a little laborious. Let's take a look at letter C, where now we have some division, right? So here, what we've got, right, is we distribute that division by 3. So we get 9x divided by 3 plus 21 divided by 3. Now again, the associative property allows me to say, well, that's going to be 9 divided by 3 times x plus 21 divided by 3. 9 divided by 3 is just 3, and 21 divided by 3 is 7. So I get 3x plus 7. And again, preferably what you're doing is you're doing, oh, I've got 9 divided by 3, which is 3, with x. Then I have plus 21 divided by 3, which is 7. The distributive property. When a sum or difference is being multiplied or divided, right, we can distribute that division or multiplication. Let's keep going. Actually, we're not going to keep going. That's it. Let's wrap this up. Next time, we will get into work with more complicated expressions and being able to combine those expressions so that we simplify our lives considerably when it comes to algebra. Today, of course, we looked at the idea of a variable, substituting a value in for a variable, and evaluating what the value of an expression is. All right. We also looked a little bit about how to use the associative properties of addition and multiplication to simplify expressions into equivalent expressions, and also how to use the distributive property to form an equivalent expression as well. All of these skills we're going to be using a lot in the next lesson, so be ready for that. For now, I'd like to thank you for joining me for another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.